Hi guys, I'm just going to run a very brief lesson on basic trigonometry. Okay, so when we're talking about trigonometry, we're talking about triangles and the angles that are involved with those triangles. So let's start off first with a basic right angle triangle. Okay, so you might remember some of this from year 10, hopefully you do. So that's my right angle there, and I'm going to call this angle here theta. Okay, now opposite to this angle theta, I have this side here, and I'm actually going to label that as opposite, and we refer to that as the opposite side. This side here is adjacent to this angle theta, so we're actually going to call that side adjacent. I'm going to give it the letter A, and you know that this is the hypotenuse. Remember, this only works for a right angle triangle. Okay, very important to remember that. Okay, so we have a mnemonic that we like to use. It's SOHCAHTOA. Okay, this tells us when to use sine, cosine, or tan. Let me give you an example. If we have opposite and hypotenuse, so the opposite or hypotenuse, and we're working with those two, then we use sine. If we're working with the adjacent and the hypotenuse, then we have cosine. And if we're working with the opposite and adjacent sides, we are using tan. Now, let's use these rules in an example. Make it a little bit smaller, so we just have the corner of our page. Let's draw a basic triangle. So I've got a triangle, and this triangle here is obviously a right angle triangle. Oops, where's my pen? It's a right angle triangle. That angle there is 30 degrees, for example. It's hard to draw that little degree symbol with this pen, but you know what I mean. The opposite side, let's just say, is 7, and the hypotenuse is x. So if I just move this triangle in the corner. Okay. So we're involved with the opposite side and the hypotenuse, which according to our mnemonic, we're using sine, opposite and hypotenuse. So what do? We write out our rule, which is sine theta equals opposite over hypotenuse. So sine 30 equals 7 over x. So x must be 7 over sine 30. Now if you type in sine 30 into your calculator, and make sure your calculator is set to degrees for now, you'll get half. So x is 7 divided by half, and that's 14. Nice and easy. Okay, so that's the first type of question we might get. The second type of question is when we have a triangle and they haven't given us the angle. We know this is always a right angle. They haven't given us the angle, and I might have this side here as 5 and this side as 10. So again, the first question we have to ask ourselves is which sides are we working with? So we're working with the opposite side and the hypotenuse. So according to our mnemonic, that's sine. So I'm going to write that again. Sine theta equals opposite over hypotenuse. Fix up the H there. So let's just zoom out a bit so it's nice and clear. So sine theta equals 5 over 10. So sine theta is half. So how do I find theta? So to find theta, I would write theta equals, now I want to find theta, so I use a button on my calculator which is the inverse sine. So it's the opposite of trying to find the side. We're trying to find the angle. So inverse sine, and I place this number here in the bracket. And that will give me 30 degrees. It's very important to remember to put our degree sign. So what it's trying to say is that this angle here needs to be 30 degrees so that this could be 5 and that could be 10. And soon we're going to find out that if that angle is 30 degrees, the ratio between these two needs to be in a way that the hypotenuse is double the opposite side. But let's not get too caught up with that at the moment. So that's just a very basic tutorial on using the sine, cosine, and tan rules. And if we just refer back to our triangle, we have to remember that the opposite side is obviously opposite. Opposite to what? Opposite to the angle. This is the hypotenuse. Remember, the hypotenuse is the diagonal side of the side that's always opposite to the right angle. And this is the adjacent side, which is the one right next to theta. And we use the mnemonic SOHCAHTOA. Thanks, guys.